This video is going to be a workflow overview or tutorial of how I accomplished this particular animation here. And basically all it is going to do is covering how and where to get structured data, how to process that data into something that can go into Blender, and then the tips and tricks within geometry nodes to utilize it to get this sort of animation here. So let's begin. So I am going to first need to find an area of interest. So I go to this website here and I am going to drag out this bounding box over mainland Europe. Once I'm content with my selection, I'll take note of this bounds down here in the bottom left, and then I'll move to where I can get my data. So I'm going to be using ERA 5 from ECMWF data, and I want to use it on different pressure levels. This data is free, but just make sure you're logged in up here. Go to download, and I want the U and V component of the wind. And since I'm interested in last June, I'm going to grab the June of 2026, all days, all time. And then I'm interested in the 500 hectopascal pressure layer. This is sort of where the primary winds that drive temperature come from. Just take a note of what my bounding box was. So it's like minus 13 to 32. And then it is going to be rounding down to 36 and up to 60. And then I'm going to take a net CDF output. I don't mess with Grib, and submit form. And this is going to process and slice out that data on their server so you can just download what you need. I'm also wanting to get temperature data from ERA 5 land, which is higher resolution. I'm just going to skip through this quickly, but yeah, basically I want all of June, and it's important that I have the exact same region as I had for the other data. And then again, netcdf, submit form, and when both of them are ready, we can download them. Now that we've downloaded our data, we need to convert it into a format that goes into Blender, and the easiest format to conceptualize and create is that of images. So basically what I'm going to do here is I'm going to load in some packages that allow me to extract the data. I also want to use a package that's going to reproject the data into a slightly more interesting visual. This first section here is to just actually grab the data, and then we need to get the range, the min and max values, because images that we're going to feed into Blender don't have the precision that this data does. It's uint 8, so you only have 256 values you can work with. After getting the ranges, I'm going to reproject the data into what I find to be a slightly more aesthetically pleasing projection. And then once I have my data the way I need it, what I'm going to do is I'm going to convert it into an image. And first I have to make sure that both the wind and temperature data have the same time steps, otherwise this won't work, or they won't line up. And then basically what I'm going to do is take the data, I'm going to normalize it between 0 and 1, normalize that between 0 and 255, and cast it to uint 8, which is required for an image. And then the temperature data is masked to the land, so I can use that information to create a mask that I can use later and apply that to my image, my temperature image. And then I'm just going to do the same thing for the U and V component of the wind. Combine them into one image array, pipe that into an image, double check that things are working, and then we just save all that out into a bunch of images. And now you can see here I have all of my images for the temperature and for wind, and now I'm ready to go into Blender. Well, actually, no, because it's important that our wind is going in two different directions, I need to know where the 0 value is in our newly normalized range between 0 and 1. So basically, we're just plugging in 0 and seeing what 0 would be in our new range. And this number, 0.4033, we need to remember for later. So finally, we get into Blender. Start by the ritualistic deletion of the default cube. I'm going to enable screencast keys, but this is going to be kind of useless since we're going to be doing most of the work in geometry nodes work area. But basically, we're going to load in an image as a plane, and then we're going to go into our shading workspace, and we first want to take our image and change it from sRGB to non-color. Basically, Blender will apply a gamma, which is a nonlinear function to images. And we wanted to not do that. We just want the raw values to come out. So that's what non-color does. And then we just convert it into an image sequence, as you saw there. And we want to do that again as well with winds. So we grab everything and again change it to non-color. And since we're using the mask from the temperature images, we keep that mask for our winds. So now all of the data is finally in Blender. Now we have to go to geometry nodes and actually utilize that. So first thing is we need to create the hair that's going to go on there. And to do this, we're going to spawn a bunch of points. And we use the distribute points on faces node. And if we look here, we can see that the nodes are very close together, not the nodes, but the points. And so that's also going to make our simulation a little bit finicky. So I'm going to scale it up by 10 so that things look a little bit better. And then I'm going to change it to Poisson disk and reduce the minimum distance so there's not like a lot of overlap. And now if I increase the density, we're going to see that the points spread out uniformly across the entire grid, which is not useful. So what we can do is use that mask that we used from the temperature and use that to delete points of interest. And so basically I drive the alpha over here and we see that's not quite what we expected because the points don't know where on the image to look. So we need to say, hey, take an inherited value that you took from your parent, the UV map, and that's your position on the image. And now delete anything according to the alpha. But as you can see, it's inverted. So actually we want to do the opposite. So we'll just use a not Boolean math mode, which is just basically inverting that. And one thing right now, I have 19,000 points. I think I want to bring them down to around 10 to 12,000 just for the preview. We also want to make sure that our mask is not interpolated. This will, since we're working with Booleans here, if it was interpolated, anything that's not a 0 is true. And since the edges are going to be a mix between 0 and 1, it's important that we just use no interpolation. Next, we're going to take every single point and we're going to put a hair or a curve on that point. And bada bing, bada boom, we now have 12,000 hairs. Now new with Blender 5.2 is in the simulation menu, we have hair dynamics. This is brand new for 5.2. We plug that into our hair. And the problem is though, we're now looking at instances, not actually hair. So hair needs to use curves. So what we do is we realize those instances and now we have 12,000 splines or curves. And now our hair dynamics can work with it. So what hair dynamics has is this thing called effectors, which is basically how it drives the simulation. And we can actually create our own custom force, which is itself an effector. So if I plug this in and I just give it a little bit of a force, we can see, wow, now it's doing some simulation. But this looks really bad. And that's because our curves only have 2 points. So we need to give it more points to run simulations on. So we can use, I guess 8 is computationally balanced. Now you can see we have a simulation of just wind blowing in from the left, and it's a constant steady wind. So now what we want to do is we want to use that wind data that we have, and we're going to use that to drive this force that's going to run our simulation. And so remember that 4033 from earlier? We need to subtract that because before it was from 0 to 1, so there were no negative values. Now we have negative values. And now I'm zeroing out any potential z values that might have snuck in. Now when we hit play, we can see that a variable force is being applied. Cool, we have our wind data driving the simulation, but it's static. What we need to do is apply some updates to the frame so that for every frame we get a new bit of data. And now when we run this, it's going to evolve and change with time because our data evolves and changes with time. And we're pretty close to being done. Like this was the hardest part about everything. And technically, and then there's the artistic part of making it look good. But the one thing we need to do is we're still working with curves and we need this to become meshes, something that's visible in a render because curves are actually invisible. So we do our curve to mesh node and then we give it some geometry and we're gonna use a curved line actually. And we want this to be very thin. So we'll do a -0.01 as start and 0.01 to end. Plug that in. And look at that. We've already got something that's looking pretty nice right off the gate. So one thing about this is it kind of looks like strips of paper. So what I want to do is I want it to taper off near the end. So what I can do is use the spline parameter node and grab the factor. And this is the value from 0 to 1 along a spline. And what I can do is fit that into a float curve. And then this will basically change the value of the factor to shape as I want my grass to look. And so I guess grass sort of starts off chunky and then at some point it tapers off to the end, something like that. And then when I'm happy with it, we can plug that into the scale, and now we have our grass that's tapering off at the end there. And there's a few more things we want to do in geometry nodes before we move into making things look beautiful. And the first is I want some of this information to pass off into the shaders. But here, I guess what I'm talking about is that they're all lined up, and I don't really like that. So I'm going to give them a little bit of a tilt. So I'm going to do curve tilt, and I'll just give them a random value of pi, and so they'll be tilted randomly. Future me here to say there was a little mistake there. If I set the tilt like I had it before, that'll actually set a random value for every single point along the spline. And so you can see the spline gets all twisty because every single part of the spline has its own unique tilt. So what you need to do is pass it through a capture attribute and do 1 per spline, and then that will be shared amongst all of the points in the spline. All right, going back. All right, so now I need to add a material to this. So we'll go ahead and move this over, and I'm actually going to first set a material just for the curves and get rid of the bottom part because I want to have a floor underneath it. So I'll just create a plane, scale it up, and then I'm just going to give it a dark color here. And now I'm going to create my material that will be called grass, and we'll come back to that in a little bit. And now I need to pass some information from geometry nodes to my shader. So basically what I'm going to do is store named attributes here. I'm going to start by just storing the fac. I might want the factor of the spline. And I'm also going to want the temperature itself. So I'm going to go over here and grab our temperature image sequence. And we can't forget the UV map, and then we need it to animate over time. So we give it the same thing as before. And now if we look at the vertices that get exported from geometry nodes, all the way to the right are our 2 new attributes that we added, and they all have a fac and a temp value. And both of these attributes will be accessible in the shader editor. So now let's open the shading menu. And I can show you that our fac and our temp attributes are now there. So if we look at the fac, we can see that it starts off at 0 at the base and then goes up to 1 at the tip. And then we can also do temp if we want to visualize temp. Let me make this not selectable so this doesn't happen. So now if we want to visualize temp, it's the same thing, but the temperature is fairly uniform at the moment, so you don't see a lot of variation. So what we can do is throw in some color. So I created an add-on. I'm plugging it here. It's free. Put a link to the GitHub. But I'm going to go ahead and grab a color map from NASA. That looked good. One shot. That was good. I'm going to delete the invalid color. And now if we look at this through this color map, now we can start to see some colors. And now from here on out, it's basically just trying to make things look as nice as possible. And it's all about, this is more about the art than it is the technique. And just for full transparency or curiosity, I ended up going with 36,000 hairs or splines that I simulated. The ground was just this dark panel. I ended up using Eevee because cycles didn't look that much better and it was going to take a lot longer to render. This was my lighting setup. Basically, I wanted to emulate the sun over Europe on June. For the color map, I used a Hiroshige color map, but I replaced the middle color, that's sort of whitish, I don't know what to call that, with a more green one because I kind of liked how that popped. And then lastly, I ended up baking it to disk, and you can see here that that bake ended up being about 22.4 gigabytes in size. And so that is the workflow I did to produce this animation.